Problem 3. A train is traveling from station 1 to station 2. If it raises its speed by 20% from the planned speed, it will reach its destination 1 hour early. So here we have if it raises its speed by 20% of the planned speed, reaches destination 1 hour early. And if it travels by the planned speed for 240 kilometers, and then for the rest of the journey travels by raising its speed by 25%, it will reach its destination 40 minutes early. Find the total distance between station 1 and 2, as well as the original planned speed of the train. So what I'm going to do right now is create the sketch. We're given two different scenarios that the train can travel from station 1 to station 2. So our first step for this type of problem where they give you multiple scenarios is to always draw the sketch. So drawing the sketch allows you to visually just see how this all works because it's usually a very complicated process that it's talking about. And then you can really, I'll call this station 1, and then you can easily compare to get the values that you need. So this is station 1, and on the right side here I have station 2. So the problem gives us two different scenarios, but really there's 3. Can you find out the 3? So there's a original speed that its plan is, that it's always compared to. So that will be our number 1. So I'm just writing 1 to show that this is scenario number 1. Scenario number 1 is when the train travels from here to here, right, with its normal planned speed, and it's just this arrow. And then we have, so we have number 2. And number 2 here is if it raises its speed the entire way by 20%. So this would be, again, what I like to do is just for whenever something is raised, I like to double it, so make it a double lined sort of thing to show that its speed is being raised. I'm just going to move this up. Okay. Maybe I'll just move both of these up. Excuse me. Okay, so we're going to move this up. And then to show that it's added with speed, then I do this. And what I like to do now is this is just 100% normal speed entire way, normal planned speed. And this is 120 of the planned speed. You might a common silly mistake that you might make is to write 20%. No, it was increased by 20%, but it's not 20%, it's 120%. And this is 1 hour early. Okay, so I'm just going to make a note there. And then our final scenario with number 3. And this is when it first travels for a portion, which is 240 km, with normal speed. So that's why this is a normal arrow here. And then I make it with added speed. So I have another line here. It's not perfect, but it'll do. In this, it says it's 40 minutes early. So 40 out of 60 minutes is 2/3 of an hour. So I'll just write 2/3 of an hour early, mostly because I want the unit to be the same all through. It's not 40 hours early, it's 2/3 of an hour early. It's 40 minutes early. Oh, and this part would be, of course, 125%. So find the total distance between station 1 and 2. So we are already done with the first part of solving this type of problem, which is, okay, I'm going to leave the question in, which is drawing the sketch. Now what we have to do is use the sketch to compare. If we compare number 1 and 2. So 1 and 2 compare. So if we compare this, then we have the time used for, time used for both of these scenarios is going to be 6 to 5. It's going to be 6 to 5. Why 6 to 5? Well, because their speeds is 5 to 6, so their time would just be its reciprocal, 6 to 5. And we know that this is 1 hour early, and 6 and 5 is already 1 apart. So this represents 6 hours over 5 hours, 6 hours to 5 hours. And now let's compare 1 and 3. Why would we compare 1 and 3 instead of 2 and 3? Well, we're going to compare 1 and 3 because 2 and 3, they just have lots of differences. If we have 1 and 3, at least you'll have part of it that's 100%, right, of the speed, but 2 and 3 don't have any parts that are the same. So that's just really hard, and you're making it harder for yourself if you do that. Of course, it's possible, but it's just harder. And especially now for 1 and 3, I'm going to do 100, I'm going to write 125% part. Why? Because when I compare this, I'm only doing the part that's after. So after this squiggly line here, I'm just comparing this part that's after the squiggly line. All right. So that is the 125% part. I'm just doing abbreviations for myself. So the time taken for 1, so time, to the time taken for number 3, so 3 time, is equal to what? That would be equal to 5 to 4. And we need a multiple of 5 and 4, a equivalent ratio that is 2/3 apart. So if we just look at all the multiples of 2/3, you'll see that what works for this would be 10/3 of an hour and 8/3 of an hour. So we have the ratio, we just have to make it correspond to this part right here. Therefore, the total distance would be 240 divided by 8 times 18, which is equal to 540 km. So our final answer would be 540 km.